Good morning students. Today I am going to present about Booth multiplication. Okay, so Booth multiplication algorithm, how it works is, okay, so for Booth multiplication means for normally the multiplication you will be having a numbers. Okay, that is it may be a signed number or unsigned number. So how we can vary the signed and unsigned number is, signed number is you will be having a minus, that is the negative operator will be represented as a signed number. Unsigned number is without no sign, it is represented as a positive number. Okay, so for this you can able to use it for multiplication. You will be applying the method of addition and subtraction algorithm. Okay, so here you will be using a two register. One is Q, another one is M, where Q is represented as a multiplicand and M is represented as a multiplier. You will be using a two register. So for example, if you are having 4 asterisk 5 means 4 is a multiplicand and 5 is represented as a multiplier. So here what we will do is, initially you will be setting a register. Okay, the two register is, one is M, another one is Q, which is for multiplicand and multiplier, and another one is the register A, which always be initially set as 0, and then there is a register called Q minus 1, the register which is used to store the carry of the addition operation after that is if you are having any one bit that is if you are having a signed number, then that bit will be stored on your Q minus 1, that is your multiplicand. Okay, so additionally there is another register A and Q minus 1. So for the multiplicand M, what we will do is, you will be performing your addition of the register and store it in the register A. So always what we will do is, we will be shifting. Okay, so we will be shifting A, Q and Q minus 1 register for one bit at the right hand side. So right hand shift will be performed for one bit. Depending upon the last bit of Q and Q minus 1, we will be performing the arithmetic operation. What is the operation we are going to perform? So what are the basic arithmetic action we can perform is, if it is the same digit number, that is 0 0 means then there is no arithmetic operation is going to be performed. If it is 0 1 means you will be performing a multiplicand, that is the add multiplicand, and you will be shifted. Okay, the product will be shifted to the left. As it is, if it is a subtract means it will be shifted from left half of the product, and if it is 1 1 means no arithmetic operation. So generally this is the signed number representation. First initially we will be converting it to a 2's complement, then it is loaded into the register. For 2's complement means, for example, if it is minus 5, so the binary value of minus 5 will be represented, and for that you will be taking your 2's complement, that is plus 1, and it is converted as, okay, for 5 means 0 1 1. So it will be taking the 1's complement for it, and then you will be adding 1 to find your 2's complement. So this is the 2's complement representation of minus 5. Yeah, so you will be following the basic binary addition operation. This is your truth representation. So 1 plus 0, you will be getting 1. 1 plus 1 means it is 10, that is 0 will be placed and 1 will be placed at your carry position, and then 0 plus 1 is 1, 0 plus 0 is 0. For example, here if the product has been given as 111, okay, that is a 5 1, which is represented as a signed number, and then if the multiplicand is in the form, then you want to perform, it will be 1 0 means it is represented as 1, 1 1 means 0, the carry will be placed as 1, then it is again 0, the carry will be placed as 1, it is 0, again the carry will be placed as, the remaining carry will be just been dropped out. Okay, this is for performing your binary addition. So this is the flow chart for representing your binary multiplication algorithm. So initially you will be starting, you will be having a register, that is A register will be initially set to 0, and Q minus 1 is your multiplier, that is it will also be set initially as 0, and M is a multiplicand and Q is your multiplier. If both the value is 0 and 1, it will be normally go to the arithmetic shifter. You will be shifting A register, Q register and Q minus 1 register, and the count will be automatically decremented. If the value is 1 0 or 0 1, okay, if it is 1 0 means you will be performing subtraction, and then you will be shifting right, and the count will be decremented. If it is 0 1 means you will be performing addition operation, and then the count will be decremented, and you will be performing the shift operation. This will be repeated again and again until the count value is 0. Okay, so this is the basic flowchart to represent your Booth multiplication algorithm. This is an example for a booth. This is for unsigned number. There is no sign. It is represented as a positive value. That is 7 and 3. Okay, so for 3 is taken as your multiplicand and 7 is taken as your multiplier. So for this you will be writing a binary representation. So here for 3, 0, 111. So it is initially set as 0. Okay, so here what you will do is 0, 11. It will be if the value is 1, 0, 1, 0 means I want to perform the first cycle will be started here. Okay, so if it is 1, 0 in your Booth algorithm, if it is 1, 0 means you have to perform subtraction. 0, 1 means you want to perform your addition operation. Okay, so here the initial value is 1, 0. So this is Q0, this is Q minus 1. So 1, 0 means you will be performing subtraction operation. So A produces A minus M. So M value is 0, 111. And then you will be performing a subtraction operation, and then you will be performing a shift right. Okay, then the count value will be decremented. So here you will be performing the subtraction. So 0, 111 that will be subtracted with 4 zeros. Okay, so you will be getting the value as 0, 0, 1, 1. Okay, so here you will be performing a right shift operation. When you are performing your right shift operation, the value will be here. After performing a subtraction, the value will be updated on the register A as 1001. So after that you will be performing a right shift operation. Then right shift operation you will be shift right. Okay, so this 0 will be moved here. Okay, this 1 will be placed here. The Q will be shifted right. Okay, so this value will be moved one step up. Yeah, after then again it will be checking for the input value. If it is 1, 1 means you can able to perform only a right shift operation. So you will be just performing your shift right operation. So this 1 will be placed here, this 0 will be placed here, this 0 will be placed here, this 1 will be placed here, this 0 will be come here. So the other bit will be added as 1. Okay, after then now the value is of Q0 and Q1 is 0, 1. If it is 0, 1 means it is represented as a addition operation will be given. Okay, so you will be performing the second cycle will be performing your addition operation. Okay, after then you will be performing your shift right. Okay, so this is how you will be performing your multiplication for your signed number. If it is an unsigned number, then how you will be performing is you will be taking the unsigned representation of 3. Okay, and then based on that you will be performing the same calculation as it is on your flowchart. Takes the 2's complement of minus 3 and perform the addition operation. Okay, for minus 3 you want to take the 2's complement, and the 2's complement value will be placed here. Yeah, and then you will be performing. If it is 1, 0, the same rule has to be followed as it is on your signed multiplication. So 1, 0 means you will be performing subtraction operation, and you will be performing your right shift operation. And then again you will be after performing a right shift operation, the value is 0, 1. If it is 0, 1 means you will be having the addition operation with your multiplication. Okay, so after then you will be performing your right shift. Yeah, and then as it is for 1, 0 means minus operation, so the count will be just being decremented. Finally your result will be right shift. Thank you so much.